This is the IoT for All Media Network. Hello, friends in IoT. Welcome to Let's Connect, the newest podcast in the IoT for All Media Network. I am Ken Briodagh, Editorial Director for IoT for All, and your host. If you enjoy this episode, please remember to like, subscribe, rate, review, and comment on all your favorite podcasting platforms. And to keep up with all the IoT insights you need, visit iotforall.com. Before we get into our episode, the IoT market will surpass $1 trillion in the next few years. Is your business ready to capitalize on this new and growing trend? Use Leverage's powerful IoT solutions development platform to efficiently create turnkey IoT products that you can white label and resell under your own brand. Help your customers increase operational efficiency, improve customer experience, or even unlock new revenue streams with IoT. To learn more, go to iotchangeseverything.com. That's iotchangeseverything.com. Now, let's connect. My guest today is Nikunj Mehta, the founder of Falkonry. Not the sport, although awesome name, but the company. And we're going to talk today about intelligence-first approaches to IoT and sort of how that helps with spreading adoption and sort of encouraging the growth of this industry that we're all working in. And, who knows where we'll go from there. So let's find out. Nikunj, welcome to the show.
Thank you for having me, Ken. It's a pleasure to be here.
Pleasure's entirely mine, and as they're about to find out, everyone that's listening too. But before we jump in, why don't you tell us a little bit about yourself and about Falkonry? I demand to know why it's called that, because that's awesome.
Yeah, let's start from there, actually. I think that's a great segue into our conversation as well. So Falkonry, as we all know, is the pairing of a beast and a man, right? A beast that is far better than any other living organism on the planet. In fact, if for those of you or those of our audience who do not know this, falcons are the fastest. They are the most powerful when it comes to the force multiplier of their own weight, and they have the sharpest vision. And so falcons have always, captivated our attention because of these qualities since time immemorial. And falconry as a sport is also an ancient sport, but mostly because the challenge in it is how do you train or tame rather a wild beast to hunt for you? Because if you can do it well, your force just multiplied 100 times over.
Sure.
And in many regards, the falconer's job is really to understand how to get the beast to do its bidding. And at the end of the day, the beast is going to fly away perhaps a season in, right? You cannot hold on to it forever. And neither should you, right? It's just not, it is not the right thing to do. And so falconry is itself a place where all of this happens. So if you think about Falkonry, the company, it's the place where falconer, meaning a subject matter expert, is taming the wild beast, which is algorithms and computers, to go do the hunting, which is finding all the problems in their manufacturing and production on behalf of that man. And the only difference is that once you get that falcon in your falconry, you're not going to let go of it.
Suppose that's fair. Although, from what I am told, occasionally it'll bite you back. So I believe I've stretched that metaphor now as far as the joke will allow me. Tell us a little bit about yourself. How did you end up founding Falkonry and getting into this sort of AIoT business?
Yes. Actually, I've been in the AIoT business for 11 years now. I started in this space with C3 IoT, now C3 AI in 2010. And ever since then, I've been captivated by the opportunity as well as the possibilities of this space. Frankly, I must also admit that my father, my grandfather, both hail from steel manufacturing. And so I've visited plenty of plants in my childhood and understand what it is like to be producing and dealing with all of the physics that arises in that environment. But when it came time to figuring out what do I do next, this was 12 years ago, I wanted to go into a field that I could, feel happy about for a long, long time to come. And I think that is what manufacturing and production is like for so many of your audience members, right? They entered manufacturing when they just finished high school and they've never left it. Probably never will. The beauty of the space is that software did not give it the sort of the fair treatment, if you might, because it's a hard field. And so we've done everything we could to make our lives more comfortable, our tasks more convenient, but software left the manufacturing space by for a while. It's great to see all this attention back, and that's what Falconry started with, is to create an even playing field for all of the manufacturing professionals to take advantage of the digital exhaust in their manufacturing context. And we believe that the continuous improvement practices like lean manufacturing, Six Sigma, continuous improvement, operational excellence, these methods, they have been perfected for a long time. And yet there's so much opportunity still left. Even though it may only be a few percentage, it's still going to translate into hundreds of billions of dollars.
Well,
And so
right.
that's what we do.
And I think that sort of the industrial space has been doing a good job over the last, say, 5 years of starting to integrate a bunch of IoT technology, especially in the realm of sort of downtime avoidance. I think that's fair to say, and focusing on that. Obviously, it's a huge issue. If unexpected downtime is hundreds of millions of dollars a year or more, but I think the rumblings are coming to want more than that, to actually get closer to this promised predictive stuff that people have been promising but not executing on for so long, and various other places where, especially manufacturing and supply chain and that piece of the industrial IoT, really is in need of machine intelligence. I think where you're able to get to the outcomes that humans are bad at finding and that machines and algorithms can find. So is that what you mean by sort of intelligence first design, is looking at how analytics will get us to that point, to those predictive and other outcomes?
I will give you a very simple analogy. You go to a restaurant so you can order high quality meals and just enjoy it right away, right? You don't go to a realtor, buy land, and go to a university, find some seeds, and wait a few seasons before you will have your first meal. Unfortunately, in a lot of the IoT space, data first approaches are very much like going to the realtor. We need to go to restaurants. And Falconry's approach is that intelligence first approach, where we have already curated the methods by which we find insights to improve uptime, to improve the quality of our production, and to increase yields from maintaining tighter control over the production processes. And that these methods apply and work regardless of the asset or the process and regardless of the industry. And that is what we mean by an intelligence first approach, an approach in which we can act upon the insights within a matter of days from when you got started. And that tells you a lot about what actually happens in your industry, in your manufacturing, and do something about it rather than wait years and years to have the opportunity to do that.
So, pardon my skepticism, but it's sort of literally my job. How exactly does that work? Because it's pretty, at least my understanding of data analytics is that it requires a certain mass of collected data. And the conventional wisdom seems to be that needs to be pretty specific to the conditions under which it's going to be operating. So how do you get that data without collecting it?
Correct. So the beauty of this is the premise of manufacturing, which is that 90% of the time, 85% of the time, and sometimes maybe 97% of the time, you are doing productive work. Machines are doing the right thing, and your production is not suffering constantly.
Sure.
Because of that, whatever it is that you're doing, you're running many different recipes through the line in a single day, or you're producing the same product, hour after hour after hour, either of those two scenarios. Your machines are telling a story in terms of their digital exhaust. And it is possible to find out what story they are telling, if not in its completeness, in the large parts within a matter of days. And that is possible because most of the behaviors that arise and that are captured in those sensors can very easily be that can easily be organized into what we call conditions and patterns. And these patterns can be learned over just a few days. You don't need to have collected years worth of data to understand what happens. And the mainstream of our customer base doesn't have years worth of historical data to work with.
So doesn't that introduce the possibility of thinking that Anomaly is regular operation, though? If you're collecting data for, say, 3-4 days to start to find these patterns and whatnot, and an anomaly appears as sort of
Beyond the 3-4 days.
right, you haven't measured it, or to me even more weird is that an anomaly has occurred previous to your starting the recording process, and now it's treated as regular. And so 3 months from
Yes.
now, when that anomaly becomes a broken machine, you have very little idea of how that happened. And is that actually a possibility? Am I imagining something?
Yeah. So you brought up a few different points here. Let's try to break it down. So first of all, if it is really unusual, even if it has occurred and we included it in the recording, it will be called out as unusual. So there is no given that whatever we started with, the period of time when we are recording, everything is acceptable. That's not an assumption. So we have to look with skepticism at the recording to know whether or not there is something unusual in it. Number two, if the unusual happened prior to your recording, then the very first time that that unusual occurs, it's going to be caught and it is going to be reported. And the reality is, in fact, this is one of the key things for us to think about, Ken. If the production is so regular and if anomalies are so rare, then naturally the question is, how are you going to do anything about it? Because every anomaly is unique. In fact, we were working with semiconductor manufacturers for whom the same anomaly does not occur more than once in even 2 years. So then how are you going to deal with those kinds of highly controlled manufacturing? On the other hand, if an anomaly has occurred prior to your starting the recording, you still have to deal with it. So the challenge at the end of the day becomes, why would anybody do industrial IoT if it is not for intelligence? And if they are going to do it for intelligence, how long do they have to collect data and give it to data scientists and engineers for them to get any value out of it? The intelligence first approach is premised on the fact that operators in their day-to-day manufacturing effort should be able to see whether the intelligence approach is giving them any value. And they can only do that if they are able to constantly see what that intelligence is telling them that they did not know about. And the longer we wait for the two to be put together, the shakier ground we are on.
That's fair. And are you using any sort of large existing data sets to inform the models and things too? I imagine that that's a resource out there that would help shorten this process as well.
Mm-hmm. Well, fortunately or unfortunately, that is not really an option.
Okay.
And I say unfortunately because every plant, every machine, every industry is different. So
Sure.
you can't just take it from one and apply it to others. People are trying. They can do that maybe for a certain class of equipment, like pumps and motors. Okay,
Mm-hmm.
but here we're talking about so many, possibly hundreds of thousands of different types of industrial equipment. How are we going to have the library for all of them? Right? So we can't.
Sure.
But on
Right.
the other hand, Falconry has been fortunate enough that customers see the promise of this approach and its performance to say, hey, I want to apply it to my equipment as well. And in the process, they validate the approach that Falconry has created that works for all the equipment. And so at the heart of this is the same approach that was used to study the human heart behavior and then was later used to study the human brain behavior, right?
Okay.
And so it's signal processing at the end of it. And signal processing is a mathematical approach. So it is stemming from the foundations of math and electrical engineering that have been around for decades.
It's really, really cool. I love this idea of sort of being able to say, now we know how it's supposed to work. Anything outside these parameters, logically adjusted, is abnormal. So let's figure out why and solve that
Why?
problem. Instead of saying, we've recorded every possible abnormality and now we know what they are, because that does seem sort of impossible.
Exactly.
My listeners are going to get so tired of me saying this, but it seems like everybody I talk to, I go, okay, this seems like a natural case for leveraging digital twin to experiment on and play with while the actual system is operating. And I'm going to say it again. Sorry, guys, because it seems like once you've created this model, you can start running a modeling twin to allow for, let's try some things. Let's experiment. Let's see what kind of anomalies maybe we can expect now in the physical system and avoid them in advance. And that sort of starts to lead us toward this predictive situation that doesn't seem to exist yet in the industrial world, but everybody wants so desperately that they sometimes pretend it exists.
Right. So, yes, we have actually looked at, for example, NASA put together a simulator for the turbofan that is used, for example, on rockets and such.
Sure.
And this simulation has existed for a while. You could inject some anomalies in it, like your sensors going bad or fouling occurring or falling off its bearing. You could introduce some of those defects. And you could produce the data from that simulator. And Falconry, for what it is good at, will tell you that it is seeing those behaviors. Very first time, it will tell you that this is an unusual behavior. What do you call it? And once you give it a name, it will tell you if it happens again with its name, right? So it does that. And one of the key things for predictive that people have been asking for a while is, tell me, how much longer do I have to get this problem addressed before I have a failure on my hands? So
Sure.
Not only that, unusual behavior and identifying what state we are in, but telling you how long you have to go before this thing will break down. So we can do all of that, right?
Right.
And you can do that from simulation. However, you cannot simulate every possible behavior. It is still too distant a goal for many organizations. They don't have the people to do that. They may not have the models because they never paid for those models.
Right.
Many manufacturers are not going to buy the design. They're going to buy the machine.
Right.
So yes, we would like to have the ability to simulate the twin, and maybe manufacturers can do it. But we also, or rather, the OEMs can do it. But the manufacturers still have to make progress, even when the OEM is not investing.
Right.
So we have to cater to all of those requirements.
That makes sense. And I think that probably speaks to why some OEMs are trying to include that in their service as a service models, where they're because I think that's good for all of the players within the ecosystem. So it makes sense that they're including those.
Yeah, I can actually tell you about one. So one of our partners is IMA Life. They are a pharma equipment maker, and they make very sophisticated freeze drying solutions that are used for packaging pharmaceutical products, basically capsules and tablets. And it is required for FDA compliance that those methods be applied for packaging. Now, it's very sophisticated computational fluid dynamics that is required to maintain a chamber of a very, very pure gas at a certain pressure level, so that you get evenness and that the product effectiveness is maintained. Now, they have all the science and they are experts at this. They've been in this business for decades. But even for them to put together the full conditional logic across all of the physical quantities that they can measure would have been an impossible job. And even if they mastered it, every two pieces of equipment, as they are used, start evolving in different directions.
Of course.
So even within one plant, you cannot get the same exact behavior to replicate. And what they found was that at some point, they could not express the problem that they were looking to avoid. Rules were just not doing it.
Right.
That kind of logic does not make sense. That's when they turn to patterns. And they're like, if you can tell me what pattern causes this problem, that's much better than us telling the computer what is the definition of the rule.
Right. And I'm just sort of incorporating this. I love the idea of, because it's just so much more mathematically sound to look at the pattern versus to say this is the rule that always works. Because yeah, you can make that prediction, but as any scientist or mathematician will tell you, most predictions end up being wrong before they end up being rules.
That's right.
And I want to move to the other part of this before we run out of time, because part of the advantage here to the approach that you're taking, as you see it, is that it speeds adoption across the industry, which obviously at IoT for All, we're a big fan of. I think that there are segments of IoT that are slower to adopt than others. Healthcare is certainly one. I think the sort of consumer space is another. We just finished CES upon recording this, although probably not when you're listening to it. But the consumer space has been way behind the industrial and enterprise space for IoT. And I'm very interested in methods to take these sort of slower developing spaces and help incorporate IoT and make the case for them. So if you could tell me a little bit about how this makes implementation easier, faster, lower bar for entry, I'd love to hear about that.
Yeah, that's a terrific question, Ken, and I'm glad you asked for it. That's been sort of the story of Falconry. Right? We've constantly been trying to make AI approachable as well as beneficial to more and more players. So only a year ago, you would have to be a company that makes at least $5 billion in goods every year to be able to adopt our AI. The cost of buying a Falconry subscription and the type of people who you would train to use Falconry, typically a production engineer, could make it difficult for people less than that to be able to do it. But now we are working with companies that are sometimes as small as a couple of $100 million in annual production. And the reason that that happens is because AI has become easier for people to apply to their operations where they don't have to learn about how to apply the AI. What they have to learn about is how am I going to take the finding that AI produced and figure out why it happened and what am I going to do about it. Those are your responsibilities regardless of the AI. Because when a problem or an incident occurs, you're going to do forensic analysis. You're going to try and find out why it happened. So, one of the biggest ways in which we know whether the AI is adoptable is what is the cost? And the second is who is going to be driving the adoption. And only when those two factors are met are we going to see this getting adopted in more places. For example, I would love to be able to understand my soil condition. I have a lot of fruit trees in my backyard. And I'd like to understand the drainage, the additions that are required, et cetera, et cetera. And I'd like to be able to do that just from putting soil sensors and monitoring it over the year and knowing at the time, like right now, what changes do I need to make so I get great fruit again next year? And will I be able to do that, or will somebody do that for me, or is there an AI that just adapts to my needs and tells me when I need to think about something? And that to me is the end goal of IoT. It will require putting more things into devices, driving down the cost even one notch lower. For example, right now, if Falconry starts at 50K per year, most companies can afford it. At 5K per year, most prosumers will be able to afford it. At $500 a month, most households will be able to adopt it.
Interesting. I hadn't even thought about the sort of household level. It's because obviously I'm thinking at enterprise level, this is a no-brainer because just the scale and everything. But you raise a good point. The idea of even if not households, certainly facilities managers, buildings, and that kind of thing can certainly find tons of reasons to look for more efficiency, more predictability in maintenance and all these other things. It makes tons of sense. So as we get near the end of our time, I want to sort of give you the floor, as it were. I suppose in sound, the floor is a different thing, but I want anything we haven't talked about yet that you think the listeners should really be taking away from the idea of AI and IoT coming together in this sort of much shorter than typically thought about process in terms of time and investment?
Yeah, I will say a couple of things. First of all, the viability of AIoT is very strong right now. What does that mean? The economic and social goals that we are trying to achieve as a humanity drive the need for AI and IoT. The value proposition of AIoT in the form of SaaS is also tenable, meaning you are going to get more benefit than you're going to spend on it. And the third is that we are moving from technology to insight. And that is the transition point where the mainstream should feel comfortable adopting. Now, in addition to this, I will say one thing because of the approaches people have taken in the bad and the bad rep that IoT has received for being too many POCs and pilots and so on. Reality is that there is no such thing as POC. If you remember Yoda, right? There's no such thing as trying, there's only doing. You've got to do it.
Yeah.
And only when you do it do you understand what are the actual on the ground difficulties for the manufacturing personnel. Like they are the ones at the end of the day who are going to create value. It's not people sitting in a lab with white suits. They are the ones who will perhaps be able to coach, maybe people like us. But the people who are going to play in the field, they are the ones which will tell us whether this is right or wrong. And for that, you have to do things. You cannot just do a POC.
Mm-hmm. That's a really, really good point. I sort of have this editorial mission that like I am so tired of the pilot program and the show me a solution, show me something in the field, show me a case study that's at scale. Those are the things I'm here for, because I think as an industry we have slogged ourselves with this is what we can do, let's figure it out, instead of saying this is what we should do and just doing it. Yes. So that I think we're turning the corner. I think companies have started seeing that and saying, yeah, that's an interesting idea. We'll talk about that later. Right now we're doing this. Mm-hmm. And I find that to be very positive. And so we're ending on a high note, which I appreciate. Thank you so much, Nikunj, for being my guest and for telling us a little bit about what you've been working on at Falkonry. So thank you for joining me. Thank you, folks out there, for listening. Don't forget to like and subscribe, etc. And come back for more on Let's Connect. I have been Ken Briodagh, Editorial Director for IoT for All, and your host. Thanks for listening, and have a great day.
And thank you very much. We'll meet you on the predictive operational excellence journey.
That sounds great. Thank you, Nikunj. Thanks again to all of you listening out there. I hope you've enjoyed our discussion, and if you have, please make sure you like and subscribe so you don't miss out on any of our episodes. We post every week, and I hope you'll leave us a rating, review, and comment on your favorite podcasting platform. If you'd like to suggest a guest, please click on the link in the description, and we also have a great sister podcast on our network called the IoT for All podcast, so make sure you check that out.
Hey Ken, let me jump in real quick and introduce your audience to another awesome show on the IoT for All Media Network, the show that started it all, the IoT for All podcast, where I bring on experts from around the world to showcase successful digital transformation across industries. We talk about use cases and IoT solutions available in the market and provide an opportunity for those companies to share advice to help the world better understand and adopt IoT. So if you're out there listening and haven't checked it out, be sure to go check out the IoT for All podcast, available everywhere.
Thank you, Ryan. Now get back to your show. And thank you all for joining us on this episode of Let's Connect. I've been Ken Briodagh, Editorial Director of IoT for All, and your host. Our music is Sneaking on September by Otis McDonald. And this has been a production of the IoT for All Media Network. Take care of yourself. You are listening to the IoT for All Media Network.